Okay, Assalamualaikum warahmatullahi wabarakatuh. So now let's continue to the new chapter, that is bipolar junction transistor. So our learning outcome for today is number 1, to understand the basic structure of the transistor. So the transistor that we will learn today is either NPN or PNP. And the second one is to understand how the transistor works based on the three region of N, P and N. And the last one is to understand the IV characteristic. So as we know, for your diode, your IV characteristic is like this. So it means more than V gamma. More than V gamma, the diode will be turned on. Less than V gamma, the diode will become off. So this is forward bias. This is reverse bias. But today we will see how is the characteristic of your IV characteristic of your BJT. Okay, what is actually transistor? Transistor have two main function. The first one is to amplify. So let's say this is a signal from your microphone. You have one microphone. So you need to amplify the signal either in terms of voltage or current. So in order to have this amplification, you need what we call transistor. So another main function of transistor is to become as a switch. So you know, as in our integrated circuit, so in your PC you have a lot of integrated circuit inside. So inside your integrated circuit is actually a lot of transistor inside. So in one integrated circuit there have million of transistor. So this transistor will behave digital, either 0, 1, 0, 1, 0, 1. It's a binary logic. So 0 means off, 1 means on. So it behaves like a switch. You see, off, on, and off, on digitally. Okay. Okay, so now let's take a look what is actually a transistor. So the name comes from transfer resistor. So we're going to, the aim of transistor, you want to have a current flow. So you will transfer from without a current, R equal infinite into R equal 0. So there is a transfer of current from a high resistance to a low resistance or vice versa. So let's take a look at one analogy of the transistor. So transistor, you can make an analogy. Transistor is like a water valve. So you know the BJT transistor, we have three part, right? We have N, P and N. So this one will be connected to your emitter, your P will be connected to your base, and your the other N will be connected to your collector. So these are three junction of the BJT transistor. So if we make an analogy, if we make an analogy of the transistor, we can imagine it's like a water valve. So the middle one here is like your base, here is actually like your emitter, and here is like a collector. So base, the valve here that is controlling the water flow. So the water flow, you can make it translate like your current. So what will happen when your transistor is on? So if you look at the water valve, so at your water valve, when you open the valve here, the water will flow freely. So means that if you want to make the transistor on, you need to control at your base. So when you open your base, your current will flow freely. Now what will happen when the transistor is off? So the transistor will be off when you are going to control the water flow at the valve again. So at the base junction, you are going to control the base junction, either it become on or off. If you close the valve, the water cannot flow, right? If you open the valve, the water can flow easily. So base play an important role to make sure the transistor on or off. Now, as we mentioned, it's like a water valve, so we can control either the water flow will become bigger or a lot of flow of water or less water will flow at the valve. So you can have a control flow here. So again at your base, you can make it either half, 3/4 or 1/4. So the water that flow from your emitter to your collector will be controlled by your base. So base play role either to become on, off, or you need to control your current. So in the water analogy here, in the water valve analogy, so your water become current flow. Okay.